Welcome to this explainer. Look, today we are doing something a little bit different. We are going to unpack exactly what Cambridge examiners are looking for when you use arithmetic progression formulas in additional mathematics, but we're going to do it by taking on the role of a film director. Scene by scene, we're going to build your blockbuster exam answer. We're going to cut out all the filler, and we're keeping only the action. So, I want you to imagine you're sitting in the exam hall. You are staring down a real Cambridge mathematics past paper question. And honestly, whether you're studying syllabus code 0580, 0606, 4024, 4037, or even 4040, the pressure is exactly the same. The clock is relentlessly ticking down. Now I want to introduce you to two typical students that we see all the time when we do these strategy sessions. First up, we've got Alex. Now, Alex is what we call the data dumper. When faced with an arithmetic progression, Alex just completely overloads the answer with raw mathematics facts. We're talking writing down every single formula under the sun, hoping something sticks, but providing absolutely zero actual analysis. Then on the flip side, there's Sam. Sam is the sprinter. Sam just rushes through the text, completely misses the crucial command word requirements, and just desperately wants to find a final number to circle at the bottom of the page. If we take a step back and look at their papers side by side, it is literally a sea of red pen marks. And you have to ask yourself, why? Because they are completely missing the ultimate Cambridge strategy.
So here is our agenda for today. We've got 5 key sections to cover. We'll start with the 15% reality, move through core principles and frameworks, and wrap up with the top examiner warnings. Let's get right into it.
Section 1, the 15% reality. Let's talk about why this topic deserves your absolute, undivided attention. Okay, what's genuinely fascinating about this slide is just this single glaring number, 15%. These formulas, and I'm talking specifically about the nth term and the sum of the first n terms, they account for approximately 15% of your total marks in the Additional Mathematics 0606 exam. I really want you to let that sink in for a second. 15% is not just some minor throwaway topic you can cram the night before. That is literally the difference between 2 entire grade boundaries. If you are sitting comfortably at a B right now, mastering this one specific topic pushes you well into an A. Senior examiners have repeatedly, year after year, emphasized that students who fail to grasp arithmetic progressions are just leaving a massive chunk of easy marks right there on the table. It is the absolute cornerstone of your exam success. Before we continue, subscribe to our YouTube channel, AC Exams, at @acexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now here is the catch, and it's a big one. While these formulas are literally handed to you, they are right there in the list of formulas at the front of your exam paper. Simply copying them down is not going to get you the marks. It is entirely about how you use them. This is exactly where our student Alex goes wrong every single time. Alex flips to the front, thinks, great, the formula for the nth term is right here, I'll just write it down. But Cambridge isn't testing your ability to copy ink from page 2 to page 7. They already know you can read. They are testing your ability to apply that mathematical architecture to complex multi-step problems. Moving on to Section 2, Core Conceptual Principles. Let's look at the foundational theory examiners are actually hunting for. The Cambridge Assessment Framework strictly prioritizes analytical depth. That means you need logical, structured reasoning, mastery of precise definitions, and the ability to integrate arithmetic progressions with completely different areas of the syllabus. This is what perfectly illustrates the difference between an amateur answer and a top-tier blockbuster answer. To achieve this level of structured reasoning, I want to introduce you to a strategy we call the PEEL framework, but adapted specifically for Cambridge mathematics. PEEL, P-E-E-L. First, the point. You need to explicitly state which arithmetic progression formula you are using and exactly why you're using it. Second, evidence. This is where you substitute your extracted values, like your A for the first term and your D for the common difference, directly into that formula. Third, explanation. Show your step-by-step algebraic manipulation. Do not skip steps. And finally, link. You have to tie your final mathematical answer back to the actual real-world context of the question. This framework is exactly how top students structure their mathematics answers to guarantee marks. This brings us to a really crucial point, summarized in this brilliant insight straight from the examiners themselves. Top students can transfer their knowledge to completely unfamiliar contexts. You see, you aren't just going to get a question that simply says, find the 10th term of the sequence 2, 5, 8. I mean, that's way too easy, right? Instead, you're going to get a question about a company's profits increasing linearly over a 5-year period. Or maybe a theatrical seating arrangement expanding row by row, or even a physics problem involving distances with constant acceleration.
The examiner is waiting to see if you can take the rigid, formal definition of an arithmetic progression and map it perfectly onto an unfamiliar, messy, real-world scenario. Can you establish that causal relationship between a block of text and your algebra? Because I promise you, that is exactly where the marks live.
Section 3, the procedural framework. Let's break down the exact methodology you need when the questions get tough. Okay, you absolutely need to master the method mark strategy. Examiners award marks for your logical process, not just that final number at the bottom. Think back to our second student, Sam the sprinter. Sam tries to do every single calculation mentally or entirely on the calculator and just writes down the final answer. The problem? If Sam makes one tiny, microscopic keystroke error, the final answer is completely wrong, and Sam gets 0 marks for the entire page. But if you use the method mark strategy, you write down every single substitution. Examiners use a highly specific grading code. M marks are for method, and A marks are for accuracy. If you show the examiner exactly how you set up the sum of the first n terms formula, you actually secure the M marks even if your final arithmetic is slightly off. You are essentially building a safety net of points as you go. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Every single time you tackle an exam question, you must rigidly follow these 5 steps. Let's do a live transformation here and see how this works in practice. Step 1 is deconstructing the question. This is your command word decoding. For example, if a question says, show that the sum is 500, you cannot just state that it's 500. You have to build the entire proof from the ground up. Step 2 is extracting the data. You need to confidently find A, find D, and find N. Step 3 is selecting your analytical framework. Ask yourself, are we looking for a specific term, the nth term, or are we looking for an accumulated total, the sum of n terms? Step 4 is execution. This means using proper bracket expansion and keeping your algebraic notation absolutely spotless. And step 5 is presentation. Present your answer using the correct mathematical terminology. This right here is the mathematics success blueprint. When students like Alex and Sam finally start applying these exact 5 steps, you can literally watch those red pen marks transform into green check marks.
All right, section 4, the deconstruct, solve, evaluate method. This is how we push your answers from standard to advanced. This specific cycle requires you to not only solve systematically, but crucially, to evaluate whether your final answers actually make sense. Let's run a quick mental drill right now. Imagine you're scanning a complex data table. You're given a scenario where a company's weekly costs are $1,000, then $1,050, then $1,100. What is the core trend there? Boom. You spot it instantly. It's a common difference of $50. So your D is 50 and your A is 1,000. Extracting that data under pressure is step 1. But honestly, it's the check for reasonableness step that will save your grade. Say you are calculating the number of terms n in an arithmetic progression, and you run the algebra and get n equals negative 4.5. You need to stop immediately. You cannot have a negative fractional number of terms in a sequence. Recognizing that and evaluating that reasonableness in real time is the absolute hallmark of a grade A student. As you can see in this table, if you want to hit those higher order requirements, you have to move past simple descriptive answers and step up to analytical comparisons and evaluative justifications. Let's try another challenge. Find the flaw. Listen to the sample paragraph from a past paper attempt. The sequence goes up by 4, so D is 4. The first term is 10. I put it in the formula and got 46. What is the massive flaw losing marks there? It is purely descriptive. It completely ignores the analytical and evaluative levels. Now, imagine a speed writing challenge. If you had 30 seconds to write a perfect Peel paragraph for that exact same problem, here's what it should sound like. To find the 10th term, I am applying the nth term formula using A equals 10 and D equals 4. Substituting these yields U sub 10 equals 10 plus 10 minus 1 times 4, which calculates to 10 plus 36. Therefore, the 10th term in this specific sequence is 46. Do you hear the difference? We are combining command word decoding with that Peel framework, establishing clear evidence and linking it all together. Finally, Section 5, Top Examiner Warnings. These are the absolute deal breakers. According to the principal examiner reports, these are the top 3 mistakes that cost students the easiest marks, and it almost always starts with poor formatting and presentation. When you forget proper formatting, you might write an expression when the question demands an equation. You might carelessly drop your equal signs down the page. Or you might just have sloppy handwriting, where a number 5 looks exactly like an S, leading you to completely mistake your own variables halfway through a complex sum formula. Listen, presentation isn't just about making the page look pretty. It is about clear mathematical communication. If the examiner cannot follow your logic flowing from top to bottom, they literally cannot award you those method marks we talked about. This right here is the ultimate dividing line. The difference between losing a mark and gaining it often comes down to this single rule. You absolutely cannot give a generic answer. It must be tied specifically to the unique data and context of the question. For instance, if the question asks, find the total distance the object travels in 20 seconds, and you do all the hard work to calculate the sum of the first 20 terms and get 850, a generic answer just scribbles 850 at the very bottom of the page. But a context-specific answer, it explicitly writes the total distance traveled by the object is 850 meters. It includes the units. It references the specific object. It proves to the examiner that you didn't just solve some abstract floating puzzle, but you actually solved the physical problem presented in the prompt. This ties perfectly back to our Peel framework's final step, the link. I really want this examiner alert to sink in because this exact issue is what separates the top percentile of students from the rest of the pack. As a quick memory hack for your exams, try using a mnemonic to ensure you hit all the key terms for your specific context. I love to use the acronym FACT. That stands for Formula, Apply, Calculate, Tie Back. State the formula. Apply your specific data. Calculate the accurate result. And most importantly, tie back to the context. FACT. So the very next time you sit down to practice, I want you to look at that blank page and ask yourself, are you truly analyzing the context, or are you just dumping numbers hoping for the best, like Alex? Make the active choice to build a structured, evidence-based solution every single time. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.